In the last lecture, we have studied about molecules and molecular mass. Now we will see some more examples on molecular mass. So, in the last lecture, we had talked about some simple molecules like methane and water. Now we will study about some more complex molecules. So, the first question is, calculate the molecular mass of glucose. Okay. So, the formula of glucose is C6H12O6. Okay. So, we need to calculate the molecular mass of glucose. So, molecular mass of glucose will be mass of carbon into the number of carbon plus mass of hydrogen into the number of hydrogen plus mass of oxygen into the number of oxygen. Okay. So, mass of carbon is 12 AMU. 12 AMU into how many carbons are there? 6. So, into 6 plus mass of hydrogen is 1 AMU into number of hydrogen is 12 plus mass of oxygen is 16 into number of oxygen is 6. So, this comes as, now we can also take the actual masses also, okay. Like for carbon we can write 12.011, for hydrogen we can write 1.008 AMU, for oxygen we can write 16.00 AMU, okay. We can take the actual masses also, but for convenience we have rounded up and we are taking the acceptable masses of these compounds, these atoms, okay. So, this comes as 72 plus 12 plus 96, okay. So, this will come as 180 AMU. So, the molecular mass of glucose is around 180 AMU. Now, if we had taken these actual masses, then this value would come as 180.162 AMU. This is the actual value. We can consider it as 180 AMU. Okay. Now, the next example, the next question is, calculate the molecular mass of oxalic acid C2H2O4 into 2H2O. Okay. So, for some molecules such as the oxalic acid or even some salts like copper sulfate, zinc sulfate, etc., some amount of water is attached to it, some molecules of water. So, for this molecular mass, we will have to consider the mass of water as well. So, let's start. So, what we'll have to do? We will have to add all these masses. So, first of all, if we take this unit, then MC into MC, that is the mass of carbon into the number of carbon, plus mass of hydrogen into the number of hydrogen, plus mass of oxygen into the number of oxygen plus, now there is 2 molecules of H2O. So 2 we will take 2 as common into within bracket mass of hydrogen into number of hydrogen plus mass of oxygen into number of oxygen. Okay. So 12 into 2 plus 1 into 2 plus 16 into 4 plus 2 into 1 into 2 plus 16 into 1. Okay. So this comes as 24 plus 2 plus 64 plus 2 into 18. This is 2 and this is 16. So 2 into 18. So this will come as 24 plus 2 plus 64 plus 36, which comes as 126. So this is the molecular mass of oxalic acid. Now the next example is calculate the molecular mass of copper sulfate CuSO4 5H2O. Okay. So similarly as we have done for oxalic acid, molecular mass of copper sulfate is equal to mass of copper into number of copper plus mass of sulfur into number of sulfur plus mass of oxygen into number of oxygen plus 5 multiplied with mass of hydrogen into number of hydrogen plus mass of oxygen into number of oxygen. Okay. So this will come as 63.5, which is the mass of copper, into 1 plus mass of sulfur is 32. So 32 into 1 plus mass of oxygen is 16. So 16 into 4 plus 5 multiplied with 1 into 2 plus 16 into 1. Okay. So this will come as 63.5 plus 32 plus 64 plus 5 into 18. Okay. So this comes as 249.5. This is the molecular mass of copper. Okay. Now if we calculate the molecular mass of potash alum. What is potash alum? This is K2SO4 Al2SO4 whole 3 and 24 H2O. Okay. So this will be mass of potassium into number of potassium plus mass of sulfur into number of sulfur plus mass of oxygen into number of oxygen, this is 1 unit, plus mass of aluminium into number of aluminium plus, see now this is SO4 whole 3, okay. So 3 into mass of sulfur into number of sulfur plus mass of oxygen into number of oxygen, okay, plus 24 multiplied by mass of hydrogen into number of hydrogen plus mass of oxygen into number of oxygen. So this will come as mass of potassium is 39. So 39 into 2 plus 32 into 1 plus 16 into 4 plus mass of aluminium is 27. 27 into 2 plus 3 multiplied by 32 into 1 plus 16 into 4 plus 24 into 1 into 2 plus 16 into 1, okay. So this will come as 78 plus 32 plus 64 plus 54 plus this term comes as 288 plus 24 into 18, okay. So this will be 174 plus 342 plus 432, which comes as 948 AMU. Okay, now we have solved so many questions, but everywhere we have done these in terms of AMU, okay. So we have everywhere measured the molecular masses in terms of AMU. Now, what if we want to measure the molecular mass in terms of gram? So, we know that 1 AMU is equal to 1.66 into 10 to the power minus 27 kg, which is equal to 1.66 into 10 to the power minus 24 grams. Okay, so let's say the molecular mass of potash alum. Is equal to, we have 948 AMU. This can be converted in terms of gram as 948 into 1.66 into 10 to the power minus 24 grams, right? So this comes as 1.57 into 10 to the power minus 21 gram. So this is the molecular mass in gram. So we can do this with others also. So let's say this, okay, the molecular mass of copper sulfate and 5H2O is 249.5 AMU. We can write this as 249.5 into 1.66 into 10 to the power minus 24 grams. This will come as 4.14 into 10 to the power minus 22 grams. Okay. So this is how we convert AMU to gram. Now let's see one other example related to molecular mass, but this one is a little different. Okay. So this is molecular mass of sucrose is 342.30 AMU. Find out the number of hydrogen present in a sucrose molecule. Okay. So the molecular mass of sucrose is 342.30 AMU. Find out the number of hydrogen present in a sucrose molecule. So what is sucrose? No, we will not talk about the molecule now. So we know the molecule of sucrose though, but we have to find out by calculation. Okay. So the molecule of sucrose is given like this: C12HXO11. Okay. So if the number of H is given unknown, okay, so we will calculate like this. We know the mass of carbon, we know the mass of oxygen, we know the mass of hydrogen as well. So what will be the molecular mass of sucrose? Will be equal to mass of carbon into number of carbon plus mass of hydrogen into number of hydrogen plus mass of oxygen into number of oxygen. Okay. So mass of sucrose is given as 342.30. This is equal to mass of carbon, that is 12, into how many carbons are there? 12 carbons. So into 12 plus mass of hydrogen is 1 into number of hydrogen is X. Okay, we have to find out. Mass of oxygen is 16 and number of oxygen is 11. Okay. So this is equal to 342.30. So we get 144 plus X plus 176 is equal to 342.30. So 320 plus X is equal to 342.30. So X will be equal to 342.30 minus 320. So X comes as 22.3. We can round it up to 22. So the formula of sucrose is C12H22O11. This is the formula of sucrose. So we have learnt about molecular mass and we have done some examples on it. In the next lecture, we will start discussion about the formula mass. Thank you.